Hello, everyone, and welcome to our lesson on experiments, designing and confounding. We have three learning targets for today. We'll be able to determine whether an observational study or experiment should be used for a given situation. We'll be able to identify the response variable and explanatory variable. And finally, we'll be able to identify the treatment, control group, and treatment group. Essentially, this is all vocab that we are going to be using as we investigate experiments and develop our own experiments. All right. Notes on page 12. Observational studies are used to learn something about a population. Experiments, however, are used to discover cause and effect relationships. That's the big difference between what we've seen before and what we're seeing now. For example, let's determine whether the teacher should perform an observational study or an experiment in each scenario. A teacher wants to learn more about what her students do for fun. Well, we could just observe them or give them a survey to learn a little bit about that. But if a teacher wants to know if music improves her students' focus during class, well, then we'll have to run an experiment to see if music actually causes better focus. So here we're looking at a cause and effect relationship. Does music help them versus just, what do you do for fun? When we run an experiment, we're going to have a response variable, and that is what we're measuring after a change in the explanatory variable. It's essentially the outcome of the experiment that we want. And the explanatory variable is what we change or measure changes in. So, for instance, if I give students music and I see if they focus better, my music is the explanatory variable and focus is the outcome or the response variable. Now, whenever we run an experiment, we're probably going to run into something known as confounding. And that's when we cannot determine if a change in the explanatory variable causes a change in the response variable. For instance, I might not be able to determine if music, in fact, causes students to focus better for a variety of reasons. Maybe they're listening to different music. Maybe the classes happen at different times of the day, so they're focused differently. Maybe some high volume music is better than low volume music or different types of music. So there's lots of things going on. How hungry the students are, that could throw off the results of an experiment and make it difficult to determine if music is in fact causing something like a student to focus better in class. All right, let's look at an example. We're going to identify the response variable and explanatory variable in the following scenario, then determine if there's any confounding. Well, if a teacher wants to know if music improves her students' focus during class, she's going to play music while the students take a test and analyze their grades. So in this case, the music is explaining the focus, which is responding. So explanatory variable is music, focus is response. And we're probably going to struggle to identify a cause and effect relationship because of things such as students' attitude, their energy level, how hungry they are, like I said before, the different types of music, etc. So there's going to be lots of different reasons for confounding. Right. A treatment is what individuals in an experiment are given. The control group is a group that does not receive the treatment, and it's used to compare against a treatment group. Now, the treatment group, probably no surprise here, is the group that receives the treatment. And it's the thing that's compared to the control group to see if there's a difference. Now, a placebo is a treatment that should not have any effect on the individual. Sometimes it's useful to give people or subjects something that you don't think is going to have an effect just because it allows you to do fancy things with your experiment. And we'll see different scenarios later on. And there are mainly two different types of experiment design. You can have a single or a double blind experiment. Now, when either the subjects or the researcher do not know is who is receiving the treatment and who is not, you're dealing with a blinded experiment. So if a subject is given some sort of medicine, but they don't know if it's the special medicine or just a normal like piece of food, they are being blinded there. They don't know what is happening. They don't know if they're getting the treatment or not. So that's a single blind subject experiment. Sorry. If the subjects don't know if they're getting medicine and the doctor doesn't know who's getting the medicine, then it's a double blind experiment. And we'll once again see more examples of this later on. But let's look at one here. Identify the treatment, control group, and treatment group. Then determine if any placebos were used or if the experiment is single-blinded or double-blind. Mrs. Z wants to know if music improves her students' focus during class. She has another teacher randomly select one of their classes to be Class A. Then she has the other teacher randomly select another class to be Class B. Class A took a test while music was playing, and Class B took the same test without music. Ms. Z then grades the test and sees that B did better than A. After she grades the test, her friend tells her that Class B was the one who did not have the music playing. So in this case, we're giving music as a treatment, and our control group is B because they weren't receiving any music. They weren't allowed to listen to any music. The treatment group is A, the ones who got the music. There's no placebos. There's nothing we're given here that people think might cause an effect. It's just music or not music. And we would consider this single blind because the researcher didn't know which group was listening to music and which one didn't. So I was doing the study and I had a teacher choose who was going to get music, who's not. I don't know who's getting it or who's not. So I'm blinded to who's going to get that treatment. So it's single blinded there. It's not double blinded because if you're sitting in a room and all of a sudden music starts playing, you kind of know something's up. So I think the subjects in that case would know that they're receiving something special. So if they didn't know what was special or what wasn't, then it would be double blind. But because only the researcher doesn't know what's going on, we consider that a single blind experiment design. If you have any questions or concerns, please let me know. Hope this video was helpful, and I look forward to working with you in class. Take care.